Hey there, welcome back to Lead Coding. Today I am with Ajay and we have planned something for you guys. So we are going to replicate an actual programming interview, and today it's my turn to be the interviewer and Ajay will be the interviewee. So I will just provide him a problem statement and then he will try to come up with the most optimal solution to that problem. So we can start with it, Ajay.
Yeah, sure. Hello, everybody. Let's start.
Yeah. So the problem statement is, do you know what a median is?
Yeah,
Yeah, so if I give you an array, how would you find the median of that array?
yeah, sure. So if it's in so first you sort the array,
Yeah,
and now if it's an even array, the median is the average of the n minus n by two and n by, the mid minus one and mid plus one element. Or if it's an odd array, then it's the middle element.
exactly.
Because in even element, you don't have a mid element, so you go one left and one right.
Yeah. All right. Now I'm going to make slight changes to this problem statement. So let us say that I am giving you some numbers. Those numbers are coming continuously to you. All right.
Yeah.
So let us say you have certain amount of numbers with you. Let us say 5 numbers. Then I will provide a few more numbers continuously, and at each stage I will ask you a query. So that query would be to return the median of that particular state. Are you getting me?
Yeah.
So for example, let us say, let me take an example over here. Yeah.
Sure.
So 3, 5, 2, 7. So this is the initial amount of numbers that you have with you. So in this case, what's the median?
Well, it would be average of 5 and 2, so it should be 7 by 2, and that should be 3.5.
Actually, we have to sort it first. So
Sorry, yeah.
yeah, 2, 3, 5, and 7. It will be the average of 3 and 5.
Yeah, sure, my bad.
Okay. Now I will give you some more numbers. Let's say 9. If I give you 9. Now when I give you 9, I will ask you again the same query to return me the median of this configuration.
Yeah, so, yeah,
So
continue.
what you can do, you can just add 9 to this sequence and then you can return 5 as the median. Now again I will give you another number. Let's say I give you 3 again. Now you will have to insert 3 and then return me the median. So this is what you have to do. So at each stage I can ask you what's the median of this configuration, and you have to return me the median of the given configuration. And another query will be to add a particular number to the initial given configuration. So these are the two queries that we have.
Okay.
Alright, so how would you proceed with it?
Okay, let's see. Let's start by, let's see if I got the correct question right or not. So I have, let's say, two functions. That first would be add, where you can give me a number and I would add that number to the continuous stream of numbers. And
Yes,
then I would have, let's say, get median, where when you call it, you should, and you can call it as a query, and you should get the median of all the current numbers in the stream, right?
exactly, yes.
Okay, so first, I guess the brute force approach I would take. Let me start by, I won't, let me just start by discussing my approaches. So I'll take this approach first, brute, call it brute. And the approach would be to first all the arrays. Let's say I have this as an array, the numbers I have. So when you call add, I would just append the number in the array. So let's say the array is a vector. I would append the number in the array, then sort it again, and then just find the median. And the time complexity in this case would be, so if I do add, that would be order of 1 to add, and then I would do a sorting, and let's say I use merge sort, then in worst case it should be n log n, and but if get median should be order of 1, because now that I have the sorted array, I can just get median.
Yeah, exactly.
So I think we can improve this law order of log n as well. So I know that I have to currently all my numbers are sorted initially. So when I have just one number, and like I start with one number, then I pick second number, then I have third number. So what I know that instead of appending it to the last, what if I append it to its correct position in the sorted array? Then I can just avoid resorting it again and again. So what I can do is I can apply binary search on the vector itself, find the position where this particular new element should go, and then insert it there. But so in that case, a problem would be inserting in the worst case takes order of n.
Yeah.
So log n should be the complexity for binary search, and insertion in the worst case should take order of n. So this will give you order of n, and get median would again be same, order of 1. So yeah, we have improved the complexity of add a little bit, but I think we can do something better. Let's call it approach to binary search, and let's discuss another approach now. So we know that we have numbers, right? Let's say 1, 2, 3, 4, 5. In the sorted arrays, sorted form, and I know that the median is the element which have all the lesser numbers on the left hand side and all the numbers which are greater than median on the right hand side. So if I find a way to kind of track all those uh, smaller numbers and all the larger numbers, and then of the set of larger numbers I pick the minimum element, that is this 4, and all the set of smaller numbers I can pick the largest number, that is 2, and then I can check if I and then I can find the median based on that. So I'll take two cases. One is even length and one is odd length. So in the even length, I would have equal number of elements in the right hand side set and equal number of numbers in the left hand side set. So I can just average these two numbers. And if it's an odd array, then I can just say whichever one has the more number of elements, the median is present in that array.
Yes, exactly. So basically, you are dividing the array into two parts. The one which is containing the left hand side or the smaller element, and you will be picking up the maximum out of those.
Yeah.
And another part will be the one which is the right hand side or the larger elements, larger than the median, and you will be picking up the minimum of that, right?
Yes. Yes.
Okay, okay, nice.
So it's very related to what I have with binary search solution. So in binary search, insertion would be there, but instead of using a vector, I can use a set that would give me insertion time of log n. So this order of n factor would be reduced, and if I use, so that order add should give me a complexity of log n, because now I'm using a set now, and get median would again be order of 1, because I can just pick up two elements, one from the left set and one from the right set, and then just average them, or if it's an odd length array, I can just pick one element. So I would the approach would be to have two sets, let's say left hand side set, left and right. Left would store all the smaller numbers, and right would store all the larger numbers that I have. And the one constraint would be the size, the left size of left minus size of right would at most be 1, because either they can be same size, or the size can differ at most by 1, so that I know that either the median is at least in one of them, or if I have to take an average or not.
Okay.
Okay. So yeah, and the insertion, the way insertion would take place is whenever you have a new element, first I would insert it in the left set, then I would take the one element from left set, and the largest element from the left set, insert into right set, and then I would check the size again. So the pseudocode would be something like this: insert into left first, then pick largest from left and push to right. That's it. Then check size. If size of left is less than size of right, then I have to do this thing that pick the smallest from right and push to left. So this should satisfy the constraint that the size would never exceed to more than one push to left.
Yeah, and which data structure are we using to store them?
Yeah, so we are using the set data structure in C++ that is actually red black trees, and that gives us an insertion, searching, and deletion type or order of log n in the worst case.
Yeah,
Okay,
all right.
so
So uh,
should I move on to implementation, or should I?
there's one more thing that I want to clear.
Sure.
You are doing the insertion. You are first inserting into the left part, and then you are picking the largest from the left part and then pushing it to the right part.
Yes.
What's the need for doing this?
Because if you keep pushing it to the left side, the constraint that the size has to be at most one, the size difference has to be at most one, that won't be satisfied, and you have to pick, if because you don't know yet that the new element is smaller than the median, or if it's larger than the median. So what you have to do is you have to insert it in left first, and then see if it's more than the size. If the size is more than right side, then you have to push it to left side. So
Exactly, yeah. So basically, when we are pushing it to the left part, we are bubbling up the greatest element to the top, and then we are pushing it to the right part.
yes, so we can, if we, before moving on to code, we can do a kind of dry run. Let's pick up this array,
Okay.
and let's try to do a quick dry run. And I have left set and right set. So first one will come. So I'll always insert the first element to the left set. So
Yeah.
let's insert one here. Now two comes. I'll push it to left set.
Hmm.
Then I see that once this is pushed, so all the ordering takes place in after the insertion. I pick up the one the so according to algorithm, I pick up the largest element from left and push to right. So I pick up two and push it here.
All right.
Now, and now the size of left is not less than right, so I won't go to this step. So this is okay. Now comes three. I push three here. Now after the ordering takes place, I push three here. But now the size of left is less than size of right. So what I'll do is I pick the smallest element from left and push to left. Sorry, smallest element from right and push to left. So this will give me this configuration. So I'll
Okay.
quickly do it for 4 and 5 as well. 4 comes here, 4 goes there, and now the size is same, so I don't have to worry. But now 5 comes here, 5 goes there, and now size is differing, so I'll push 3 here. Okay.
All right. Correct.
And so now this is the add part, and when I go for get median, what I'll do is I'll check the size of left set and right side, and if they are differing, I know that the size of left, either the size of left is going to be size more than right, or
Yeah.
if it's going to be same. So if it's same, I'll just pick up the left. Let's assume we had a 6 as well. So I'll pick the greatest element from left and the smallest element from right, and I'll take their average. So this is equivalent to taking average of 3 and 4. And if I didn't have this, then I know that left size is greater, so median should be 3 in this case.
Correct. Yes.
Okay,
Yeah. Now we can move to the coding part.
sure. Uh, let's start by taking a vector of these numbers. This is our infinite string. Let's call it that. And let's create these two sets, left and right. And I have this add function, which gives Given a number, it will first add it to left set. Sorry. Then, according to my algorithm, I insert into left first, then pick the largest from left. Okay, it's giving me some issue. What is the error? Did I forget something?
Where is it giving you error?
Reference to left is ambiguous.
Left dot size.
I think I should just pick LR. That fix it. Yeah, that fixes it.
Yeah.
Now I have to pick the largest element, and since this L set largest is the last element, so what I can do is I have to push it to left. So in right dot insert L dot R begin. So that gives me the pointer to the last element, and since it's a pointer, I can use the dereferencing operator to get the value.
Yes.
Right. And now what I have to do is I have to pop it from left as well. So what I can do is left dot erase, and left dot end points to the one ahead of the last element, so I can use previous operator to decrement it and erase the last element.
Yeah, or you can use the decrement operator, pre-decrement operator as well.
Yeah, sure. I can just use. I can just store it ln first, decrement it, and then use it.
Yeah.
Okay. And now I have to check if the size left dot size, if it's less than right dot size, then I have to do the same thing. I have to first remove the smallest element from right, insert into left, and then remove it from right as well. So I think I can reuse this code a little bit. So I have to insert in the left part. I have to insert r dot begin, and that should be this. And from the right, I have to erase r dot begin. Okay. Does this sound correct?
Yes.
Okay. And now for the get median function, like get median it can return a float. So let's take a float. And so whenever I get this query, I have to first check size of both. So what I'll do is I'll check L dot size. If the size is same, sorry, R dot size, then I will just return, or I can just use 0. L. So it should be the largest element from left set, and that is going to be at begin at the end. So I can use R begin operator. And the smallest element from left set, so I can use r dot begin. Okay, and
Okay.
If this is not the case, I know that the left size is always going to be greater than the right, because we ensured it right here.
Yes. Yes.
Okay, and so I can just return L dot r begin, the last element, and this should be dereferencing. And let's assume that this is our infinite stream. So, and after inserting each number, we can query the get median part. Let's try that. So
Yeah.
after this is the R. So first I'll add the number, and then I'll output get median. Okay, should we give it a try?
Yes. We can run it.
Okay, sure, let's try. It gives me output 1. So after first should be 1, then 1 and 2 should be 1.5.
Yeah.
Then 2, then 3 plus 2, 5 by 2 or 2.5. Then it should give me 3, and then at the end it should be 7 by 2, 3.5. I guess it works.
Yes. It's working fine.
All right. So I guess we have discussed time complexity as well.
Yes, the
Uh,
time
uh,
complexity is for each query it is log n for the addition, and for the get median it is big O of 1.
yeah. I think one can solve this using priority queue as well. Instead of using sets, you can use the same functionality with priority queue as well.
Yeah, using heaps we can implement the same functionality.
Yeah. Yeah.
So is there any benefit of using heap over these?
Yeah, because see in this set, the constant factor, the see complexity would be same, but the constant factor that comes in. So for this set, the constant factor. Yeah, so time complexity of both approaches using set and priority queue would be same, but the constant factor in this part, it's larger for sets and smaller for priority queue. So the actual execution time would be less for priority queue.
Yes. All right, so this was a pretty good solution. Would you like to take a challenge? Like, I'm going to give you a bonus question.
Sure.
Yeah, so let us say that if I give you the input within the range 1 to 100,
Okay.
how would you make optimization to that? All the inputs are from the range 1 to 100.
Okay. So now I have assumption over the distribution of the numbers. So every all the numbers are from 100. So I already have a pretty good login solution. Where can I optimize it? Let's see.
In case you want a hint, you can ask me anytime.
Sure, just give me a few seconds before asking for it.
Yes, sure.
I guess I know that all the numbers are from 1 to 100. I can. What if I take an array from 1 to 2 to up to 100, and then uh, each time I get a number, I can just store its frequency in the array, like the way we use in count sort kind of
Yeah,
thing. And but so addition would in that case, I guess, would be order of one. But
yeah,
when I do get median, let's see if that helps. Get How would I get median in that? One way to actually kind of generate a new array, but that is not going to be a good solution. What I can do is, yeah. So in median, I know that. So in median, I know that if let's say x number nth number is median, let's say, then I know that before the median there should be and after the median there should be equal amount of numbers.
yeah. So the frequency, we are talking about the frequency here. The
Yeah.
frequency
So yeah,
before that
if the
number. Yeah.
frequency should be or the cumulative frequency should be same of the
Exactly.
left part and the right part.
Yes,
So
yes.
I suppose we can work on that. Uh, so frequency, let's see, of each number. But if I calculate, if it if it is indeed the, I think we can maybe apply binary search over this.
Hmm. What about if you already know the cumulative frequency of all the elements present there? Let us say you know the cumulative frequency of all the elements which are already present inside your array.
Yeah, I
So,
mean, I can kind of build a prefix array over that, over this,
mm,
to get frequency. But how,
uh,
how would I go and say, okay, this is the nth number, then I have to check for, okay, I know that all the numbers are from 1 to 100. I can just iterate from 1 to 100.
exactly, yeah.
Yeah, sure. Okay, I can just because this is a small number, so it's going to be more or less constant. And for each number, I can just calculate the frequency or the left part cumulative frequency, right part cumulative frequency, and if it is indeed the median, then I should be able to get that answer. So let's say if I'm doing it for nth number, and the left part. For n, I should have frequency. Okay. What if there are repetitions, because there are going to be repetitions. So
Repetition
uh,
of numbers, right?
right.
So
So
that is why we are storing the count.
yeah, but I mean, but if I do have that, how would I know if this is in? Just give me a second. Okay, what if I left left part and n plus oneth number left part. In overall frequency, I know. Let's call it sum, and number it should be s by 2. Let's say if I have s numbers, then there should be, and let's say s is even. Let's say s is odd, then there should be s by 2 numbers on the left side and s by 2 numbers on the right side.
Yeah.
And for the nth number that I have computed the frequency of left part, and if it is less than if it is more than s by 2, I know that it is not a solution.
So you are calculating the cumulative frequency for each of these
Yeah, so
elements.
what I can do is I can iterate from for I equals to 100 to it was 1, right?
Yeah.
I can do, and I will calculate the left part frequency, cumulative
Mm-hmm.
let's call it frequency, and let's call it B. And if B is more than S by 2, I know that it is not solution.
Yeah, so that's what you can do. But instead of calculating the cumulative frequency, what you can do is, because you can't actually maintain a cumulative frequency array, a prefix. You can't maintain a prefix array, right? Because
Right.
we are getting a stream of data and it's always changing. So what you instead you can do is, if you know the total summation of all the numbers, right? If you know the total amount of numbers that are there,
Yeah.
including the repetition, and then you will know that the if they are sorted, the and the summation is s, then the median will be present at the position s by 2. All right.
I see. Yeah.
Yeah, so what you can do is, you can start iterating from 1, and you can keep adding up the frequencies, and at any point, if the frequency becomes more than s by 2 for any number,
Yeah.
so that number might be the answer.
Yes.
And in case you can handle the case of odd and even like this.
Uh, I think this is what I was kind of trying to do for this part. I Instead of traversing from left to right, sorry, 1 to 100, you can traverse from 100 to 11. And so you said that when it is more than s by 2, you know that that might be solution.
Yeah.
So what I'm saying is, until you are getting s by 2, keep going. But when you hit less than s by 2, break.
Yes,
So
yes,
that
yes.
might be solution. So I was traversing from right to left.
Okay,
So
okay, okay. Yeah.
we are kind of going on this same direction. For the left part, you are right. We cannot maintain a prefix array, but since it's only an array of 100 size, we can just calculate it using a for loop, and
Yeah.
that shouldn't be an issue.
Yes. So this way we optimize both space and time. We are not doing some login operations there, simply big O
Right.
on operations. There's a slight optimization when the constraints are from 1 to 100.
Right. So yeah, that was a pretty good solution. Yeah.
So it was a really good experience with you, Ajay. Really nice solution.
Yeah. I enjoyed it too. Yeah.
All right. So thanks a lot for your time.
Thank you.
All right.
Bye bye, everyone.
Bye bye. Have a good day.
You too.